Okay, for this particular problem, this shows the relationship between delta G, delta H, and delta S. That's Gibbs free energy relating to enthalpy and entropy. So in this case, we will need this equation. Delta G is equal to delta H minus T delta S. And to find out if this process is spontaneous at 25 degrees, we just plug in some of these numbers. So delta H here is given as 53 kilojoules. Temperature is 25 degrees Celsius, but that must be put into Kelvin. That's 298 degrees Kelvin. Delta S is 115 joules per Kelvin, but we need to change joules into kilojoules because this is in kilojoules. So with that, we can figure out delta G. So that's 53 kilojoules, and this is 34.27 kilojoules. So that is equal to 18.73 kilojoules. Since this is a positive delta G value, that means that this is a non-spontaneous reaction at 25 degrees Celsius. So to figure out if this reaction is spontaneous at a higher temperature, 250 degrees Celsius, we just plug in some of the numbers again. So 250 degrees Celsius plus 273. Change that number to Kelvin. And here we get a delta G of negative 7.14 kilojoules. Since delta G here is a negative value, then it is spontaneous. To figure out the answer for C, at what temperature does delta G equal to 0? Well, we use the same equation, but basically then putting 0 is equal to delta H minus T delta S. Here delta H again is 53 kilojoules. T is what we're looking for, and delta S again is given by these values. So solving for T. So T is equal to 460.8 degrees Kelvin, or changing that to Celsius, 188 degrees Celsius. So this is the temperature where delta G is equal to 0. Again, delta G, when it is equal to 0, this is at actual equilibrium.